Hi everyone, I'm Shubham Jhavar. I'm a master teacher at Vedantu. We are discussing KVPY 2019 essay part 1 mathematics, and the question for this video is this. Let n1 be equal to 2 to the power 55 plus 1 and n2 is equal to 165. Then there are 4 options and it is a single correct type question. First option is about n1 and n2 being co-prime, that means HCF being 1. Second one says HCF 55, third one HCF 11, fourth one HCF 33. So basically we are concerned about highest common factor between n1 and n2. So first of all, n2, which is 165, clearly is 3 multiplied by 5 multiplied by 11. So we are essentially concerned whether n1 is divisible by 3 or not, whether n1 is divisible by 5 or not, whether n1 is divisible by 11 or not. Here, let me first go for whether it is divisible by 11 or not. So, as I go for 2 to the power table, that means 2 to the power 1 is 2, 2 square is 4, 2 cube is 8, which is 3 away from 11, 2 to the power 4 is 16, which is 5 away from 11, and you may say 6 away from 22. 2 to the power 5 is 32, which is 1 away from 33, which is a multiple of 11. So what will I consider? I'll consider 2 to the power 5 whole to the power 11 plus 1, and 2 to the power 5 is 32, which I'll write as 33 minus 1 whole to the power 11 plus 1. So this is what n1 is. Now, as I expand this using binomial theorem, what would I get? I'll get 11c0 33 to the power 11 minus 11c1 33 to the power 10 plus 11c2 33 to the power 9 minus plus alternate, and ultimately you would get minus 11c11 33 to the power 0. Essentially, in this last term, we are giving 0 power to 33 and all 11 powers to this term minus 1. So effectively, it becomes minus 11c11. Now, 11c11 is 1. So minus 11c11 is minus 1. And mind it, there is plus 1 more there apart from this binomial expansion. This plus 1 is there, which we write here. So this cancels out. And if you see carefully, all other terms are multiple of 33, because a term just before this last term would be 11c10 multiplied by 33, because in that will give 10 power to this minus 1 and 1 power to 33. So this minus 11c11, which is essentially minus 1, and this plus 1, they essentially cancel out. And all other terms are multiple of 33. That means n1 is divisible by 33, and hence it is also divisible by 11, and not just 11, in fact it is also divisible by 3. Why? Because 33 is 3 multiplied by 11. So if something is divisible by 33, it is also divisible by 11 and also divisible by 3. Now all we need to check is whether n2 is multiple of 5 or not. At this point of time, if you see options, you would realize that answer is supposed to be D. Why? Because if n1 is multiple of 5 also, then the highest common factor between n1 and n2 would be 165, which is none of the options. I mean, none of the options says that HCF is 165. Since n1 is also divisible by 3 and 11, same as n2, so that means HCF of n1 and n2 is supposed to be 33, and D is supposed to be the answer as per the options, because one option out of these 4 must be correct. So D is the answer. Nonetheless, let's check whether n1 is divisible by 5 or not. Again, this we are checking just for our inquisitiveness, so to speak, and just for the completeness of the solution. Otherwise, at this point of time, it is very clear that among the 4 options, D is correct. Now here, just as I have considered 2 to the power 5 whole to the power 11 instead of 2 to the power 55 to check whether n1 is possibly divisible by 11 or not. Similarly, here I may consider for divisibility by 5, I may consider 2 multiplied by 2 to the power 54 plus 1. I may consider n1 as this. Why? Because 2 is 3 away from 5. 2 is square, which is 4, is 1 away from 5. Yeah. So I'm interested in, considering 2 square. So it becomes 2 times 2 square to the power 27 plus 1. Now 2 square is 4, and 4 you can write as what? 5 minus 1. Yeah. Now again, as you expand using binomial theorem, you would get all terms which are multiple of 5 except the last term, which would essentially be minus 1. If you see carefully, first you will be giving 27 power to this term 5 and 0 power to minus 1 divisible by 5, so and so forth. Second last term would involve giving a 1 power to 5 and 26 power to minus 1, again divisible by 5. And the last term involves giving all 27 power to minus 1 and 0 power to 5. So it will be 27C27, which is 1 multiplied by minus 1 to the power 27, which is minus 1. 1 multiplied by minus 1 is minus 1, and that's exactly what we have written here. And 2 in product comes as it is. So now what you are essentially getting is, you get it to be, 5k multiplied by 2 is like, you may say 10k. And 10k I may write as, again, let's say 5m, because 2k I'm taking as m. And what you are getting is minus 1. So definitely this expression is not a multiple of 5. In fact, it is of the form 5m minus 1. In fact, you may go on to say that when you divide n1 by 5, the remainder is supposed to be 4. So clearly not multiple of 5. So D is my answer. Let's see some other way of doing this question. Another interesting way of doing this question is, you may say n1 to be 2 to the power 55 plus 1. Yeah. So it essentially is 2 to the power 5 whole to the power 11 plus 1 to the power 11 is what you may write. Basically, it becomes 32 to the power 11 plus 1 to the power 11. You may see it this way. Now the point is, when you have x plus y whole to the power n, this is divisible by x plus y if n belongs to odd natural number. That is, x plus y is a factor of x plus y whole to the power n if n is odd natural number. So here 11 is odd natural number, so that means this expression is divisible by 32 plus 1, which is 33. So n1 is divisible by 33. Hence, it is also divisible by 3 and also by 11. That means, HCF between n1 and n2 would at least be 3 multiplied by 11, which is 33. And again, as per options, D is the only correct answer. But again, just for inquisitiveness, let's explore whether, n1 is multiple of 5 or not. And again, let's take some other method, some other approach. If you see carefully, 32 to the power 11 you may write as 30 plus 2 whole to the power 11 plus 1 to the power 11 is 1 only. Now, divisibility by 5 involves whether the unit place digit is 0 or 5 or not. Because for divisibility by 5, the unit place digit, the ones place digit should either be 0 or 5. So here, the ones place digit would be decided by 2 to the power 11 term here. Why? Because, in all the other terms, if you see again by binomial expansion, 30 would have at least 1 power. That means there will be 0 at the unit place. So that means the unit place digit would be decided by 2 to the power 11, the last term in the expansion of this binomial. So, and plus 1 of course would be there. So, if I'm looking for unit place digit, I would be considering 2 to the power 11 plus 1. And 2 to the power 11 is very simply, 2 to the power 10 is 1024, 2 to the power 11 is 2048 plus 1. So what you get is 2049. So that means 9 is the unit place digit of n1. Hence, it is not divisible by 5. In fact, what we were saying, that remainder, in fact, when you divide n1 by 5 would be 4. So you can easily understand now that since the last or you may say unit place digit or ones place digit is 9, when you divide n1 by 5, the remainder would be 4. So n1 and n2 both are divisible by 3 and 11 only when we talk in terms of prime numbers. So that means HCF would be 33. Thanks for listening. Stay tuned for the next question.